Find all vertical asymptotes and create a rough sketch of the graph near each asymptote. So we're looking for vertical asymptotes on this example. So to find vertical asymptotes, we need to write this function in factored form, and the numerator is x plus 6, which is already factored. Denominator is x squared minus 36. This is a difference of squares. We can write this as x plus 6. For this question, we want to find all vertical asymptotes and create a rough sketch of the graph near each asymptote. But when we're looking for vertical asymptotes, we need to first find any restrictions we have on this rational function. So we're going to do that by setting the denominator equal to 0. We set that denominator x squared minus 11x plus 28 equal to 0. And we can solve this quadratic equation by factoring. X times x would give us the x squared. 7 times 4 will give us 28. And we need both of these to be negative to create that negative 11 in the middle. And we can set each of these factors equal to 0. And that gives x equals 7 and x equals 4. So this rational function has some restricted values at 7 and 4. But those restricted values might not be vertical asymptotes. They could be vertical asymptotes, or they might be something called a removable discontinuity. So we need to check to see if this function has any common factors. The numerator is already factored into x plus 6, and the denominator, we factored that into x minus 7 times x minus 4. And you can see that we do not have common factors between the numerator and denominator. So that means that both of these are vertical asymptotes. So this function has 2 vertical asymptotes. And then we want to draw a rough sketch of the graph near each asymptote. So there are a couple ways that we could come up with this rough sketch. One of them is with something that we call a sign chart. So what we're going to do is we're going to draw a number line. And on that number line, we're going to put all of the factors, or not the factors, the zeros of the factors from the numerator and denominator. So we already got the zeros for the denominator, that's 7 and 4, but we also want to use the 0 from the numerator as well, which would be negative 6. We're going to put those numbers on this number line. That's negative 6, 4, and 7. I'm making sure to put them in order from smallest to largest because our number line goes from left to right, smallest to largest. And over here, I'm going to list the factors that we have. We have x plus 6, x minus 7, and x minus 4. Let me draw a little grid for these different factors. The one thing about these factors is that they are all linear factors. They all have a positive slope. So when a linear factor has a positive slope, the graph will change its sign. So on the left here, all the y values are negative. So that's to the left of your x-intercept, or 0. And to the right of your x-intercept, all the y values are positive. So I can make this sign chart based on that information. So let me draw. I'm going to draw little vertical dashed lines on all of these numbers to separate out my number line. And for this factor of x plus 6, it has a 0 of negative 6, and it will change signs over that value. That value is the 0. So remember, we said here it changes signs over the 0 or the x-intercept. So it's going to be negative to the left of that 0, but positive to the right of it. Then the next factor is x minus 7, which has a 0 of 7, so it's going to change signs over that 0. It will be negative to the left of it and positive to the right of it. Then we have a factor of x minus 7, which, oops, I wrote the same factor twice, so this should be x minus 4. And x minus 4 has a 0 of 4, and it will change signs over that 0. So to the left of it, we have negative, and to the right of it, positive. So we do that for each factor, and then we're going to multiply all the signs together. So if I multiply these three signs together, a negative times a negative times a negative will be a negative for that interval. We multiply these three signs together. A positive times a negative will be a positive. We're going to multiply these three signs together. A positive times a negative will be a negative. A positive times a positive will be a positive. Okay, so let me explain why we did all that work. We have our asymptotes at 4 and 7. And now I know that to the left of 4 we have a positive, and to the right of 4 we have a negative. So that's going to tell me that the y is going to go to infinity on the left and negative infinity on the right. And for my vertical asymptote of 7, I now know that on the left is a negative and on the right is a positive. And so on the left, the graph will go to negative infinity, and to the right will go to positive infinity. So if I were to sketch a graph near these vertical asymptotes, here's my coordinate plane. I'm going to mark 4 and 7, put vertical asymptotes at 4 and 7. To the left of 4, I'm going to positive infinity. To the right of 4, to negative infinity. To the left of 7, to negative infinity. To the right of 7, positive infinity. So that gives me a sketch near those asymptotes. So I showed you how to get those pluses and minuses from the sign chart. But if that is confusing or maybe too much work, you can also choose test points. So let me just get a different color here. So I could choose test points on either side of my asymptotes. So I want to choose a number that is smaller than 4, so maybe 3.9. And I want to choose a number that's bigger than 4, maybe 4.1. And I'll choose a number that is smaller than 7, 6.9, and a number that's bigger than 7, 7.1. And if we substitute these values into our original function, we should get the sign as well. So we can substitute f of 3.9. Let's get our calculator out to make this more convenient. Okay, so I've got my calculator here, and I'm going to substitute into the numerator 3.9 plus 6 divided by 3.9 squared minus 11 times 3.9 plus 28. And all we need to pay attention to is whether we get positive or negative, and we got positive. And that matches what we saw on our graph. Then we do it again for 4.1. So we have 4.1 plus 6 divided by 4.1 4.1 squared minus 11 times 4.1 plus 28. This time we got a negative. Then we do f of 6.9 we have 6.9 plus 6 divided by 6.9 squared minus 11 times 6.9 plus 28, and we got a negative, and then f of 7.1 gives us 7.1 plus 6 divided by 7.1 squared minus 11 times 7.1 plus 28, and we get a positive. So hopefully you see that that matches. We got positive to the left of 0, positive to the left of 4, negative to the right of 4. Negative to the left of 7, positive to the right of 7. So we could get the same pluses and minuses, which tells us that the y goes to infinity or negative infinity. For this question, we want to find the equation of all horizontal asymptotes, if any, of the rational function. We're working with the function f of x equals 6 over x plus 9. Now, the actual math or calculation involved in finding horizontal asymptotes involves calculus. Since we're doing this in an algebra class, what we're going to do instead of the calculation is that a bunch of scenarios or cases have been summarized for us, and we're going to memorize those different cases and be able to identify the horizontal asymptote from that summary. So we do have a little bit of memorization to do to be able to answer these type of questions. So what we need to do is know what the cases are. And in our cases, the first one is that the numerator degree is smaller than the denominator degree. In the next case, the numerator degree is equal or the same as the denominator. In the third case, the numerator degree is bigger by 1, bigger than the denominator degree. And in the final case, the numerator degree is bigger by more than 1. So in order for us to figure out which case we're working with, we have to know the degree of the numerator as well as the degree of the denominator. Now the degree is going to relate to the power on x. So for our denominator we have x plus 9. So let's analyze this. We have x plus 9. Each term has a degree. So this term has a degree of 1 because the power is 1. This term has a degree of 0 because there is no variable. And then the degree of the overall polynomial or denominator, we're going to take the highest of those degrees. So the degree of the denominator is 1, and we call that m. Now for the numerator, we have 6, and the degree of something without a variable is going to be 0, and it's the only term, so we know that the degree of the numerator is 0, and we call that n. So we can see here that the numerator degree is smaller than the degree of the denominator. So n is less than m in this case, and that's usually how we label this instead of with words with symbols. The degree of the numerator is smaller than the degree of the denominator. So our function is in that first case, and what we do is we memorize in that first case that the horizontal asymptote will be y equals 0. Anytime the degree of the numerator is smaller than the degree of the denominator, the function has a horizontal asymptote of y equals 0. Now, in the other cases, you have no horizontal asymptote if the numerator has a bigger degree. So in both of those cases, the numerator degree is bigger, and there's no horizontal asymptote. And in the case where they're equal to each other, you have a horizontal asymptote, and you have to do a little calculation. It's going to be y equals the ratio of the leading coefficients. That's an LC, leading coefficients. So to just put a final point here, for this particular example, because the degree of the numerator is smaller than the degree of the denominator, this particular rational function has a horizontal asymptote at y equals 0. On this example, we want to find the equation of the horizontal asymptotes, if any, of the rational function f of x equals 7x squared minus 5x cubed over 6x cubed plus x squared minus 9x plus 7. So when we're finding horizontal asymptotes, as we've said before, the math behind finding horizontal asymptotes involves an operation called limit, and that is a calculus concept. Now, since we're in an algebra class, we're not going to do the calculation. The rules have been summarized for us into 4 cases, and we're going to find the horizontal asymptote with a little bit of memorization of what those cases are. So what we're going to do is we're going to identify the degree of the numerator, which is n, and the degree of the denominator, which is m, and we're going to compare those numbers to each other. And that's going to give us the 4 cases. So the first case involves n being smaller. In symbols, we write that as n being less than m. The second case involves the 2 degrees being equal to each other. So n is equal, n equals m. The third case involves n being larger than m, but by only 1. So n is bigger by 1. And symbolically, I would write that as n being m plus 1. N is 1 more than m. And then the last case is n also being bigger by more than 1. And symbolically, we write that as n is greater than or equal to m plus 2. So these are the 4 comparisons that we can come out with. And then we've got to memorize what the horizontal asymptote is in each one of these cases. Maybe I can make this a little bit neater with a chart. So in the first case, when the numerator is smaller, you're going to have a horizontal asymptote right along the x-axis, which is the line y equals 0. In the second case, when the degrees are equal to each other, your horizontal asymptote is going to be y equals the ratio of the leading coefficients. In the third case, we have no horizontal asymptote, and in the fourth case, we have no horizontal asymptote. So you may be wondering why we would separate those two out, and the reason is because there is a different type of asymptote called an oblique asymptote or a slant asymptote, and when your numerator is bigger by 1, you do get this other type of asymptote. So the oblique asymptote is a line, y equals mx plus b, and that is, you can find that using long division. Okay, so now that we understand the different cases, we need to identify the degree of our numerator and the degree of our denominator. So starting with the numerator, we have 7x squared minus 5x cubed. And if we look at the individual terms here, we can identify the degree of an individual term, and that degree is the power on x. So we have 7x squared has a degree of 2, and 5x cubed has a degree of 3. And then we identify the degree of the whole expression to be 3, and that is the highest of the degrees. So we now know that n is 3. The degree of the numerator is 3. But then we're going to look at the degree of the denominator. So our denominator is 6x cubed plus x squared minus 9x plus 7. We can look at the degree of individual terms. The degree of 6x cubed is 3. The degree of x squared is 2. The degree of 9x is 1. And the degree of 7 is 0. There's no variable, so the degree is 0. Then we look at the whole expression, and the degree of the whole expression will be the highest, which is 3. So we've identified the degree of the denominator to be 3. And now when we compare the degree of the numerator to the degree of the denominator, we can see that the two degrees are equal to each other. And now that we know that we're in the second case, we're going to be able to find the horizontal asymptote by using the ratio of the leading coefficients. Now, that language might be a little bit confusing because it uses the word leading, L, for leading, but Leading doesn't actually mean first. Leading is only first when you write your terms in descending order. This numerator has not been written in descending order, so you might, by mistake, identify 7 as the leading term, and that would be wrong. Your leading term is always paired with the highest degree. So your leading coefficient from the numerator would be -5, and your leading coefficient from the denominator would be 6. And the line y equals -5/6 is the horizontal asymptote for this expression. So just to go back to the original for a second, this is the highest degree term from the numerator, and this is the highest degree term from the denominator. We're going to use the ratio of those coefficients. So this one was kind of tricky because they wrote that numerator out of the typical order, which we call descending order. And so you might have, by mistake, identified the wrong leading coefficient. On this question, we want to find the equation of all horizontal asymptotes of the rational function. And the rational function we have is f of x equals x squared minus 169 over x plus 13. Now, in this example, we're going to be finding the horizontal asymptotes in an algebra class. So the actual math behind finding horizontal asymptotes involves an operation called the limit, and that's something that you learn how to do in calculus. So in an algebra class, what we do is we try to summarize the rules so that we can find the asymptotes by following these different scenarios. So these rules that we follow involve looking at the degree of the numerator and the degree of the denominator. So you'll notice that in all of these rules we're using n and m, and those are the degree of the numerator and the degree of the denominator. So let's take a look. In this example, the degree of the numerator, n, is equal to 2. That's the highest power on x. And the degree of the denominator is 1, and that's the highest power on x. So if we're thinking about these different cases, I think it's pretty easy for us to eliminate n equals m. And I apologize there. I wrote this as n. It should be m. So I think it's clear to see that they're not equal to each other. But we need to figure out which of these other ones we have. Okay, so when we look at this first one, n is less than m. So I'm going to translate that to words. That says, it's actually right here. The degree of the numerator is less than the degree of the denominator. The degree of the numerator is less than the degree of the denominator. You can see that that's not true. And in the next one, if we put that in words, the degree of the numerator is 1 more than the degree of the denominator. So in this case, the degree of the numerator is that 1 more, that's a plus 1, 1 more than the degree of the denominator. And I can see that this is true. The degree of the numerator is 1 more, 1 bigger than the degree of the denominator. So this one is the one we want to use. So in that case, there is no horizontal asymptote. It does have what we call an oblique asymptote or a slant asymptote, but this question only wants to know about horizontal asymptotes. So on this one, we can say that there is no horizontal asymptote. Thank you for checking out my videos. Have a great day.